This video is on perimeter, area and volume. So this is all to do with shapes. The perimeter is the total distance around the outside of a shape, and your answer will be just in millimetres, centimetres, metres, kilometres, something like that, because it's just a distance, so it's just a length. The area is the amount of space inside a flat 2D shape, like squares, circles, triangles, trapeziums. If the shape is drawn on squared paper, you can just count the squares inside to get the area. And if you're estimating, then you count the squares that are half or more coloured in, because sometimes they're not perfectly whole squares. So just count the ones that are half or more coloured in or shaded. Your answer for area will always be millimetres squared, centimetres squared, metres squared after it. These are your units of measurement, and sometimes in the exam you get 1 mark just for writing down the right unit of measurement. So because you're counting the squares, your answer is always something squared. Volume then is a bit like area but for 3D shapes. So shapes that you could pour water into, so things like cubes and cuboids and triangular prisms and cylinders, they would be 3D shapes. And if it's made up of small cubes, so sometimes they give you a cuboid and you're able to count how many wee small cubes make it up. So if you are able to count them like that, then just count them and that will get you your volume. And your answer will always be in millimetres cubed, centimetres cubed, metres cubed, etc. So because you're counting the cubes, your answer is always cubed for your units of measurement. So perimeter is quite straightforward then. You're just looking at the total distance around the outside. So the ones that I really want to focus on in this video are area and volume, because you need to know your different formulas, which are different depending on what the shape looks like. So first of all then, starting with area. So these are 4 different formulas to do with area. So the first one is just for squares and rectangles. So for you to find the space inside those shapes, you just do the base multiplied by the height. And that would get you the same as you counting how many squares are inside if you do the distance across by the distance going up. So that's for squares and rectangles. For a rhombus or a parallelogram then, it's actually exactly the same formula, because a rhombus and a parallelogram is just a square or a rectangle slanted over. So the angles change inside but the area doesn't change. So a rhombus or a parallelogram, it's just the distance across times by the distance going up. The only difference is here, the distance going up, it has to be the straight up height, the same as what it is here. And a lot of the time in the exam they'll have labelled this slanty one just to see if you're silly enough to use it really. So you never ever use the slanty sides here whenever you're finding the area. It's just the base times the perpendicular height going up. Then for triangles, it's the base going across times by the height going up and then divide by 2. So for triangles, the base times the height would get you the area of a rectangle, and a triangle is half of a rectangle or half of a square, so that's why you divide by 2 at the end. And it doesn't matter what the triangle looks like, whether it's scalene, isosceles, equilateral, it's still the base going across times by the height going up and then divide by 2. But similarly, whenever we were doing the parallelogram, it was the perpendicular height that you used, so you need to make sure you use the straight up height here and not any of those slanty heights. So the one that goes straight up from the base is the one that you use. The trapezium then is the only formula that is slightly more complicated. So this one is given to you at the front of the exam paper. They don't expect you to know this one off by heart. They expect you to know those 3, but not this one. So the area of a trapezium is given by the formula half a plus b h. So you do what's in the brackets first of all, a plus b, and they give you this picture on the formula sheet. So they tell you that a and b are your parallel sides. So you add those together first, add the parallel sides first, and then either half it and times by the height, or else times by the height first and then half it. It doesn't matter which way you go after this, whether you times by the height and then half it, or half it and then times by the height. Whatever is easier depending on whether you've got a calculator or not. Then at the bottom here, I've just put when you're using the height, it must be the one that goes straight up from the base. So the same thing goes here for the trapezium. You have to use the perpendicular height, not either one of these slanty ones. It has to be that height going straight up from the bottom to the top. The distance between the parallel sides there would be your height. So I've just got a few questions then using these different formulas. So the first question, find the area of the following shape. So the first shape that I've got here is just a rectangle. So I just do the base times height. So always write out your formulas. So base times height is 7 across times by 3 going up gets you 21. And then these measurements are in centimetres, so your answer will be centimetres squared. Part B is a parallelogram, and the area of a parallelogram follows the same rule as the rectangle, just base times height. So the base going across is 8, and the perpendicular height going up is 4. We don't use the slanty 5. So 8 times 4, 32, and these units are all in centimetres again, so centimetres squared for your units of measurement. Then part C and D are both triangles, so you'll do base times height and then half it. So for this one, you would have base times height equals 4 times 3. Don't use the slanty 5, use the base and the perpendicular height, and then divide it by 2 will get you 6, and it's all in centimetres, so centimetres squared again. So base times height divide by 2 is your formula. And then the same idea for part D then. So the base this time is 4 and the height is 4, and you don't use the slanty 6. So base times height, first of all, would get you 4 times 4 is 16. That would get you the area of a square or rectangle, and then divide by 2, because triangles are half that size, will get you 8. And this is all centimetres again, so centimetres squared. Okay, so that's rectangle, parallelogram and triangle. The next few questions then are shapes which are called composite shapes because they're made up of different rectangles and squares. So find the area of this shape. This one looks a wee bit like an L shape, and there is no formula for finding the area of an L shape, so you have to do it by splitting it up into different shapes that you do know how to find the area of. It doesn't matter whether you split it up going across or going down. So for this one, I'm going to split it up going across like that, and I'm going to call that shape A. And then the other shape at the bottom, another rectangle, I'm going to label it shape B. If you label them A and B, then the examiner who's marking your paper will be able to see clearly where your answers are coming from. So the shape A then, this wee bit up at the top, it looks a wee bit like a square, but don't just assume that it's 3 by 3, actually use the other lengths on the picture to work it out. So this 10 is going the whole way from the top down to the bottom. So 10 is the total distance of the blue one and the green one. We just want the height of the green one. And over here we're told that the 7 is the height of the green one. So if the green one's 7, then the blue one would have to be 3 to get you a total of 10. So 10 take away 7, that distance up, take away that distance up will get you 3. So yes, it looked a bit like a square, but don't just assume that. So shape A then, it's just base times height for that square. So 3 times 3 equals 9 centimetres squared. And then the green one at the bottom, same formula again, base times height again, and it's 8 across times by 7 going up. So 8 times 7, 56 centimetres squared. And then you would add these two together to get the total area. So we're wanting the total area of this whole shape, which would be the blue one and the green one added together. So 9 add 56, we'll put it up to 65 centimetres squared for your total area. Part B then, or shape B, same kind of idea. You don't know how to find the area of this random shape, so you need to split it up into shapes that you do know the answer to. And this time there's going to be 3 different shapes. Doesn't matter whether you split it going down or going across. I'm going to split it going across. So one rectangle, label it A. So rectangle A down here then. Another rectangle, label it B. And then, what about that? The last wee one there then, we will label it C. So again, labelling them, forgot about that, but again, labelling them just will show clearly where your method is coming from or where your working out's coming from. So rectangle A then, base times height. Again, they're all rectangles, so you're just using base times height. So the green one, it's labelled clearly there, 4 going across, 3 going down, so it's just 4 times 3, 12 centimetres squared. Rectangle B is 9 going across, okay, but you don't know the height of it. You don't know what that height is there. You know that the 8 is the total distance of it, and then you know that 3 is the height of the green one, and we're just looking the blue one. So you would have to do the total height 8 of the green one and the blue one, take off the green one, which is 3, and that will leave you with the blue one as 5. So 8 take away 3 would get you 5 for the blue one. So that's 5 in there. So 9, oh, meant to write down there base times height again. So base times height, 9 times 5, 45 centimetres squared. The last one then, shape C. It's going to be quite awkward to find the lengths of these here. So that 6 was for the blue one and the yellow one, and I've already written 5 down here for the blue one. So although it doesn't look like it, that is actually 1 centimetre. It happens like this sometimes in the exam. It'll say not drawn accurately, so don't be surprised if you get a length that looks nothing like it should be that length. Like to me here, the 5 and the 6 kind of look, or the 5 and the 1 kind of look the same length, but they're not. This one here then, going across, so we know the total distance is 9 going across, and we've got a 4 and a 3, so 4, 5, 6, 7, this must be 2 here to bring you up to 9. So for shape C, it would be 2 times 1, base times height, 2 times 1, 3 centimetres squared, and then you just need to add those 3 together to get your total area. So 5, 6, 7, 8, 9, 10, and then 4, 5, 6, so 60 centimetres squared. That's not the only way for you to do those shapes. You could have split them up differently with the lines going down. It really doesn't matter which way you do it. Just make sure that you're definitely using the right lengths. Then number 3, find the area of the following shapes. So there's 2 different ways that you can do these ones. You can split them up the same way as I did the last question into rectangles and triangles, but the easiest way to do them is if you're able to recognise that they're trapeziums. So if you recognise that they're trapeziums, then you can use the formula, and it's given to you at the front of the exam paper. The half A plus B H. Half A plus B H. So the first thing you do is spot which ones are the parallel sides and add them together. So normally in the exam they would have the arrows on them to show you that they're parallel. So those 2 sides there are parallel to each other. So that's what I do first, add those parallel sides. So add the 9 and the 5 would get me 14. And then I can times it by the height and then half it, or else half it and times by the height. So the height that I would be using for this one would be the height going directly between the 2 parallel sides, which would be that one. And then I don't use the 7. So if I'm trying to do this without a calculator, adding the 9 and the 5 gets me 14. It's probably easier if I half the 14 now. So divide the 14 by 2 to get me 7. And then times by the height and do 7 times 6 equals 42 centimetres squared. That it just works out a wee bit nicer than having to do 14 times 6 and then half it if you're trying to do it without a calculator. So that would be the area of that trapezium. It's a whole lot easier and a whole lot quicker than splitting it up into a rectangle and triangle. Part B then, the same kind of idea, so another trapezium. So you need to add the parallel sides first of all, so that would be adding the 6 and the 10. So add those first of all, so 6 add 10, not 16. So 6 add 10 gets you 16. And then you need to work out which height is the one that you're going to use. So you're wanting the perpendicular one, so that would be the 3 that you use then, not the slanty 4. So you either do 16 times 3 and then half it, or half the 16 first and then times it by 3, whichever way you find easier. I would normally times by the height and then half it, but I'm trying to do this without a calculator, so I'm going to half it first. So add the parallel sides and then half it. So half that gets you 8, and then times by the perpendicular height. So times by the 3 will get you 24, and it's all centimetres again, so centimetres squared. Okay, without you recognising that they're trapeziums, you wouldn't even know to use the formula. So you really need to be able to identify your shapes and be able to recognise that they're trapeziums and not parallelograms. So look out for 2 parallel sides and then these other 2 sides not being parallel, and that will tell you that it's a trapezium then. And remember, this formula is given to you in the formula sheet, you just need to know how to use it. So add the parallel sides, times by the height and divide by 2, or add the parallel sides, half it, and then times by the height. Okay, the next shapes that we're going to be looking at are circles. So all of those shapes that we're just looking at there now all had straight sides, so you need to be able to do the perimeter and area of circles as well. So first of all, you need to know all the different parts of the circle. So this diagram here has everything labelled on it. So first of all, the actual circle, so the outline of the circle, the fancy name for that is the circumference of the circle. Handy enough to remember because it starts off with the same way, or starts off with the same 4 letters as circle, so circle, circumference. The other 2 most important lines are the one going from the middle out and the one going the whole way across through the middle. It is really important that you know the names of those 2 lines. So the radius is the one that just goes from the middle out. It's the shorter one, and it's the shorter word as well, so that should be handy to remember. And then the diameter is double the radius. It goes the whole way across from one side of the circle to the other through the middle. So those are the most important ones to know. The circumference is around the outside of the circle. It's the actual outline of the circle, the distance around the outside of it. The radius is halfway across, the diameter is the full way across. These other words, the only reason why you really need to know those is because sometimes they just give you a picture of the circle and get you to label it, or they've got parts of it labelled and they want you to say which bit is which. So other bits inside the circle then. The chord is a wee bit like the diameter because it goes from one side of the circle to the other. It goes from that bit of the circle to that bit of the circle, but it doesn't go through the middle, so that's how it's a chord and not a diameter. An arc is a wee bit of the circumference. Think of arch, like an archway in a house or under a bridge or something like that. So an arc would just be like that wee bit of the circumference. I didn't do the chord there, I'll go back and do it. So that would be the chord going from one side of the circle to the other, not through the middle. The arc is a wee bit of the circumference. Then these 2 bits here that are shaded in, they aren't lines of the circles, they're actual like area bits of the circle. So you have a sector is like a slice out of the circle, like if you were taking a slice of pizza or a slice of cake or something like that, that would be a sector of the circle. And then the other bit that's shaded in there, it's a segment. So it is a slice out of the circle, but not a normal slice the way you would take, like if you were taking a pizza slice, it would be like that. You're not going to cut your pizza like that. So the sector is the one that's properly like a slice of pizza, and then the segment is just separated by a chord. So you've actually got a major segment, minor segment, major sector, minor sector, the proper names for them. The last one there that we haven't looked at is the only one that is outside the circle. All the other ones are inside. So if it just is a straight line, comes and touches the circle and then goes away on off, that one is called a tangent. So I remember this one because it starts off with the word tan, and you get a tan, like a suntan, whenever you're outside, and it's the only one that is to do with the outside of the circle. So the most important ones there that we're going to be using now are the circumference, the radius and the diameter. We're not really going to be coming across these ones again. You only really need to know how to label them, what they look like, where they are in the circle. There's no formulas to do with a tangent or a sector or a segment or a chord or an arc. So the 2 formulas that we're going to be using them. If you want to find the circumference around the circle, you do pi times the diameter. This wee symbol pi, it's a Greek symbol, and it is just a shorter way of writing a really long number. So the pi button on your calculator, if you press it, it'll come up as 3.14159 and so on. I'll just bring it up on the calculator to show you. So on my calculator, the pi button is down there at the bottom. That tends to be where it is on all of your calculators, whether it's a Casio one. The Sharp ones, I don't think have it down here at the bottom actually. They have it on a button up here on its own. But most of you seem to have a Casio calculator, so it'll be down here at the bottom. So to get it, you press Shift and then that middle bottom button, and you'll see the pi symbol coming up on the calculator. If I now press equals, it'll just show you what number it is actually equal to, but you're not expected to write out this big long number each time. You just use the wee pi symbol instead. And actually, if you don't have a calculator, like if it's the non-calculator paper, then they would allow you just to leave the wee pi symbol in it, or else they'll tell you to use pi equal to 3 or pi equal to 3.1 whenever you're doing your calculations. So back to these formulas then. So the circumference is pi times the diameter. So the distance across the circle, the diameter, if you multiply it by about 3, that'll get you the circumference around the circle. And the about 3 bit is where the pi symbol comes in. So the circumference is pi times the diameter, and it's shortened down to C equals pi times D. So just the first letter of circumference and the first letter of diameter. So just remember, like in music, CD, those two letters go together, C and D. Then the area, if you want the space inside the circle, you do pi times the radius squared. So not the diameter this time, it's the radius going from the middle out. So pi times the radius and then squared, because your areas are always squared. Or A equals pi times R squared would be the shorter version of it. Just the first letter of the area used and the first letter of radius used. So try to remember this one, because the word area starts with A and then R, and those are the two letters that are used in the formula. You need to know these ones off by heart, because they're not given to you in the exam. They're not on the formula sheet. You're expected to know those ones. Okay, we'll take a look at some questions then on circles. So question 1, calculate the perimeter and the area of the following shapes. So we'll take it one shape at a time. This first one, it's just a whole circle. So if I was wanting to find the perimeter of this, the perimeter is the fancy word for the circumference of the circle, so I use the circumference formula. So circumference is pi times diameter. And then you go to your picture, so pi times, and you need to work out where the diameter is. So that 8 that you've been given is going the whole way across the circle, so that's your diameter. So your diameter is 8. So pi times 8, and if you don't have a calculator, then you just write that as 8 pi centimetres. Or if it's in a calculator paper, they would expect you to go to your calculator, do pi, oh, there's the pi button there, pi and then times by 8 equals. And then just round it to 1 or 2 decimal places. So 25.13, I'm going to go to 2 decimal places, 25.13, and then that would just be centimetres, because that's just a length that we found, it's just a perimeter. So 25.13 is the total distance around the outside of the circle. Then if you're wanting to find the area, you use the area formula, pi times radius squared. So just because you've been given the diameter doesn't automatically mean that you use the formula with the diameter in it. If you're asked to find the area, like we are in the second bit of the question, then you have to use the area formula. So it's pi times, and then you need to go to your picture to get your radius. If your diameter is 8, the radius would be half of that. So you would have a radius of 4 there, either side. So pi times 4 squared, or pi times 4 times 4. If you were doing that without a calculator, which you could do very easily actually, you would just do 4 squared, 4 fours are 16, and then stick the pi symbol after it, so just 16 pi centimetres squared. Or if they told you that pi was equal to 3, you would be able to do that without your calculator as well. I'm going to stick with using the pi symbol. So I'm going to do shift and then the middle bottom button to get the pi button up, or the pi symbol, and then times by 4. And if you don't know where your squared button is, then just times by 4 again. but there's my squared button there. So I'm just going to press the squared button and then equals. And then round that to 1 or 2 decimal places. I'll stick with 2 decimal places, so 50 point, and then the 2.6 would go up to a 2.7 because of this 5 after it. The 6 goes up to 7. So 50.27. 50.27 centimetres squared, because it's an area and areas are always squared. The second shape then, find the perimeter of it first. So finding the perimeter, we would use circumference equals pi times diameter. So pi times, go to your picture, again that 5 is your diameter, so it will just be pi times 5. So go to your calculator, pi times 5 equals 15.71 to 2 decimal places. So that answer is the total circumference the whole way around the circle, but this isn't a full circle, it's a semicircle, so I don't want the full curved bit. So what you would do now is divide that by 2 because it's a semicircle. So divide by 2 gets you 7.85. So what we found now is the distance around the curved bit of the shape. That's that distance that we found, but that's still not your total perimeter, because the total perimeter is the total distance around the shape and back to the start. So what you need to do at the end there then is add on the 5, add on the straight bit. So add on the 5, we'll total it up to 12.85 centimetres. So that's the circumference, the total circumference around the, or sorry, not the total circumference, the total perimeter around the circle. So you've got half of the circumference of a circle and then plus the straight bit. So the other bit of the question then, we were asked to find the area inside. So area is pi times radius squared. So pi times, go to your picture, if your diameter is 5, then put that in half and your radius would be 2.5 at each side. So pi times 2.5 squared. So go to your calculator and do pi times 2.5 squared would get you 19.63. But again, it's not a full circle, it's a semicircle, so you need to divide that by 2 then to get the area of half a circle. So divided by 2 gets you 9.82 centimetres squared, and that's the end for that bit. You don't then go and add on the 5 because this has nothing to do with the perimeter, that's just the area inside the shape that we found. So you wouldn't find an area and then add on a straight bit, that doesn't make sense. So that's the end for that one. The last question I want to look at then with circles is just finding an area like this. So I want the shaded area, just those 4 wee bits at the corner of the shape. So if you were making this out of card or something like that, you would cut out a square first of all, so find the area of a square, and then you would cut out the circle in the middle, which means that the area of the circle is being taken away. So for you to find the area of this shape, you would have an area of a square, and then you would also have the area of the circle, and you would take them away to get those wee bits around the corners. So the area of the square is just base times height, so that would be 18 times 18, so times those together, 324. And then for the circle, so the area of the circle is pi times radius squared, so pi times, again here your diameter is 18, so your radius split in half would be 9 and 9, so you would do pi times 9 squared. So go to your calculator, pi times 9 squared gets you 254.47, that would be 254.47. So that's the area of the entire square in the background, so that would be all of that. And then take away the circle in the middle would leave you with the 4 bits around the outside. So take that off, 324, and you're left with 69.53. And this was all in centimetres, so your answer again there would be centimetres squared. Okay. The next bit that we're looking at then is volume. So the volume is the space inside a 3D shape. So for your volume, you could either do, I'll do this one here first and then I'll come back to these formulas. So the shape below is made from centimetre cubes. What is the volume of the shape? So this is the easiest way for you to find the volume, where it's just made out of wee blocks. So you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 centimetres cubed would be the volume of that shape. Just count the wee cubes and then put your answer as centimetres cubed. For all the other shapes at foundation here, they're all prisms. And what I mean by a prism is that they are shapes that stay the same shape the whole way through. So these ones here, if they were made out of chocolate or something like that, or cheese, something that you could chop up, if you were to take a slice off the front of that, it would be a rectangle. And if you keep slicing right to the back, everybody would get the same piece, the same size of rectangle. So it's a prism, it stays the same from the front to the back. The same with this triangular prism. It's a bit like a Toblerone bar, and if you think about Toblerone, the first piece of Toblerone is the same size as the last piece of Toblerone, so it stays the same from the front to the back. The same with this parallelogram prism. The parallelogram at the front is the same as the one at the back. This trapezium prism, the trapezium at the front, stays the same right through to the trapezium at the back. They're not always sitting facing that direction though, so this cylinder is sitting up on its end. So the cross-section area isn't always the face at the front. It's just the face that stays the same the whole way through. So for this cylinder, it would be the circle at the top, and it stays like that circle from the top right through to the bottom. On the front of your exam paper, on the formula sheet, you are given for volume, you are given that formula there. Volume of a prism equals cross-section area times length. And you're also given that wee picture, and it shows you on the front of it that the front of the shape is the cross section, or the bit of the shape that stays the same from the front to the back is called the cross section. And then what you do to turn it from an area into a volume is that you times by this distance going back. So you find the area of the front or the top face, whatever the cross section is, and then times by the depth going back, and that makes it 3D volume. Okay, so the first shape here is just a cuboid. So the cross section for that would just be that rectangle at the front. So I'm going to find the area of the rectangle. So first of all, I would always write out the formula. So volume equals cross section area times length. Then do a wee arrow down from cross section area and write out your formula for the cross section. So the cross section of that rectangle is base times height, so that would be 10 times 5. So 50 for the cross section. So that's the area of the flat face at the front, and then times it by the depth or the length going back, times it by the 2, and that turns it into a volume. So 100 centimetres cubed. So 50 centimetres squared is the area at the front, times it by another 2 centimetres, and that will put it up to 100 centimetres cubed. So that's the volume inside that cuboid. For cuboids, a quicker way to do it is just by doing your length times breadth times height, which you might have come across in junior high, but that doesn't work for all of your prisms. It won't work for your triangular prisms or your trapezium prisms or your cylinders. So I would maybe just stick to that formula, because then it definitely works for all of them, and then you can get used to using the same formula. Question 3 then, wanting to work out the volume of this. This is a parallelogram prism. So you would shade in your cross section at the front, so that's your parallelogram. Write out your formula, volume equals cross section area times length. An arrow down from your cross section area and write out your formula for the parallelogram, which is base times height. So that would be 11 going across by the 7 going up. So 11 times 7 is 77. So that's the area of the parallelogram at the front, that's the flat area. And then times it by the distance going back, which is 2 again for this question, and that will turn it into a volume. This time the units of your answer, that's inches, inches, inches. So your answer would be inches cubed or cubic inches. Question 4, work out the volume of this triangular prism. So the cross section face this time is a triangle. So volume equals cross-section area times length. And your cross-section area is a triangle, so you write down base times height divide by 2 for your formula. So your base would be 6.4. In this picture your height is also 6.4, and then divide by 2. So go to your calculator and do 6.4 times 6.4 divided by 2. Gets you the area of the triangle, so 20.48. So that's the area of the flat 2D triangle at the front. And then you times it by the length going back, so times it by the 8.3, and that will turn it into a volume. So times by 8.3 turns it into 169.98, and these are all in millimetres, so your answer would be millimetres cubed this time. So that's your volume for that one. The number that you multiply by at the end is always the number that actually turns it from a 2D shape into a 3D shape. So if that was just the triangle at the front, that's just a 2D triangle. It's these lines going back that make it 3D. So that's why you times by the 8.3 at the end to get it into a 3D volume. Okay, a few more of these sorts of shapes then. So the next one is a trapezium prism. So the cross section this time, you've got a trapezium at the front. So you write out your formula, volume equals cross section area times length. Put an arrow down from the cross section area, and this time the area at the front is the trapezium, and the formula for your trapezium is the half A plus B times H for this one. So you add the A and the B first. Remember, the A and the B are your parallel sides, so that would be the 7 and the 9 that you would add together. I think I possibly said times there a minute ago, I'm not sure. So add the parallel sides together, so add the 9 and the 5. Would get you 14, then half that gets you 7, and then times by the height of 4 would get you 28. Okay, you could just do all that on your calculator in one go if you wanted. So add the parallel sides, add the 9 and the 5 gets you 14, half that gets you 7, times by the height of 4 gets you 28. And then that's just the area of the flat trapezium at the front. So that's not including these lines here going back. So once you include these lines and make it into a 3D shape, you need to times by the 6. So the last step there is to times by the 6 to actually turn it from an area into a volume. So 28 times 6 gets you 168. These are all in centimetres, so this one would be centimetres cubed. Okay, that's probably one of the more awkward ones, mainly because so many times people don't know that that's a trapezium at the front. They think that it's a parallelogram. Okay, so look for something that looks like the roof of a house or a boat. If it's sitting up the other way around, look for 2 parallel sides and the other 2 sides not being parallel. Number 6, work out the volume again. This is a cylinder this time, so your cross-section area is a circle. So volume equals cross-section area times length. Your cross-section area is the circle, so the area of a circle is pi times radius squared. So we need to work that out first. So pi times, and if you go to the circle, that 7 that they've given you is your radius, so you just use it as it is. The radius goes from the middle out. So pi times 7 squared then. So pi times 7 squared gets you 153.94 for your cross-section area. And then for you to turn it from an area into a volume, you times by the number that makes it 3D. So without those lines going down, it's just a flat circle. So times by 15 to turn it into a 3D circle or cylinder. So times by 15 gets you, it's a big answer, 2,309.07. These are all centimetres, so centimetres cubed. Right, the next question. Wanting to find the volume of this shape. This isn't any of the shapes that we know the formula for. It's an L shape, so a bit like we did the, I'm just getting the other sheet, a bit like how we did those areas. That's how you would find the area of the cross section for this. So that is your cross section area that you're wanting to find. So this time you would have volume equals cross section area times length. And then from your cross section you would have 2 different areas. So you would need to split it up. Looking to see if there's an easy way to split it up. No, not really. It's split it up going down this way, or this time. So there's shape A. And then the other one, shape B. So your cross section area, shape A, the distance across by the distance going up, your base times height. The 10 is fine, you see it clearly, it's going up, but we don't know this distance going across. We know the 12 is the total distance going the whole way across, and we know that 8 is the distance going across the blue one. So from 8 up to 12, or 12 take away 8, means that the yellow one must be 4 across. So for the area of the yellow one, it would be 10 times 4 equals 40. And that one would be millimetres squared, because we're just looking at area at the minute. Then shape B, the distance going across is 8, down is 3. So your base times height would be 8 times 3, which equals 24. And then you would add those two areas together, which gets you 64. At the minute though, that's just the area of the cross section at the front. And we have completely ignored all of these lines going back that make it a 3D L shape rather than a 2D L shape. So the number that you need to times by there is the 2 going back. So right at the end then you would do 64 times by 2. So that's the length going back that you times by. So 64 times by 2, 128. And that turns it into millimetres cubed for your volume rather than millimetres squared for your area. The last question then is one that's a wee bit different. We're going in reverse this time. So the cuboid below has a volume of 48 centimetres cubed, and we want to work out the depth of the cuboid. So we're wanting to work out that depth there going back. So if you start by writing out your formula, cross section area times length, your cross section area would be that rectangle at the front, which is base times height. So that's 8 times 3, so 24 is the area of the cross section, and we are timesing that by some length going back and getting an answer of 48 for the volume. So just 24 times what will get you 48. If you can do it in your head and you know that 24 times 2 gets you 48, then that will get you that depth going back. If you can't do that in your head, then do 48 divided by 24 to get 2 centimetres would be the depth going back on the shape. Okay, so that's the end of that bit for perimeter, area and volume. Just one last wee bit that goes in with all of these different topics are nets and surface area. So the net of a 3D shape is the flattened out version of the shape before it's been built up. So the net of a shape is what it looks like when it's been flattened out before it's built up into a 3D shape. So if you were actually going to make some of these shapes out of card or something, then it would be the shape that you would draw out in the card before you fold it up to make it into the 3D shape. And if you're asked for the surface area, that's just the area of the net, the area of all of the surfaces. So just total up the area of all of the faces. So for this one you would just have 1, 2, 3, 4, 5, 6 rectangles totaled up, the area of 6 rectangles. This one you'd have 3 rectangles and 2 triangles totaled up. These shapes here, they would expect you to be able to recognise the net and match up the net with the 3D shape. And then there's one of them in particular, the cube or the cuboid, that they would expect you to be able to draw the net out accurately. This one they would expect you to be able to maybe sketch it and maybe sketch this one, but the main one that I'm going to focus on here is just the cube or the cuboid, because they expect you to be able to draw it out accurately using all the right lengths. So this diagram shows a cuboid. We are asked to draw an accurate net of the cuboid on the grid below. So the way that I would do this is take the biggest number, so take the 5 and go across 5. I'm going to do this in pen just so that you can see it more clearly. So go across 1, 2, 3, 4, 5. So go 5 across, so that's that number used. And then the other two numbers that we've got are 2 and 3, and I would do those going time about down the page. So go down 2 and make a rectangle out of that. Then go down 3 and make a rectangle out of that. Then go down 2 and make a rectangle, and then go down 3 and make a rectangle. Obviously if you were doing this you would use your ruler and a pencil. I'm just not using it here because those lines are very thick and you wouldn't be able to see the pencil properly. So go down 5 and then 2, 3, 2, 3 going down your page. The reason why you need to do it like that is because if this is the base of your cuboid, so sitting at the bottom, these two sides here would fold up and face each other. That one would go to the front and that one would go to the back, so they need to be the same size. And then this one would flip right over and go on the top and be facing that one. So that's why you need those two to be the same size. The last bit that would need to include then are these two bits sitting at the side. So we've got the bit that would roll around the middle. We've got the front, back, top and bottom. We don't have these two bits here at the side. So the way to get those to be the right length is whatever you go down here, that's what you go out. So down 2, go out 2, down 2, go out 2, because those two edges will be meeting whenever you fold it up. And then you just need to make this all go in a line. So make sure that the second row of rectangles are all sitting in line with each other. Okay, sometimes with these shapes people are able to visualize it perfectly. They can see exactly what way it would fold up, but sometimes they're not. So that's one way that you can do it without really having to think about it. Do the 5 going across, then 2, 3, 2, 3 going down, and then go down and out, and then make these all sit in a row together. The last bit of the question is calculate the surface area of the cuboid. So that's the area of all of the faces. So the area of this rectangle, it's 5 by 2. So this one has 10 squares inside it. This one here also has 10 then. This bigger one is 5 by 3, so it has 15 squares. That one has 15 squares. 2 by 3 would have 6 squares, 6 squares. So the surface area is all of those numbers totaled up. If you want to, you could just sit and count up all the squares, but you might make a mistake at some stage, so I would do it maybe rectangle by rectangle. So the final answer then would be 15 plus 15 is 30, plus 10 is 40, plus 10 is 50, plus 6 and plus 6 would be another 12, so that brings you up to 62 if I've added that up right. So 30, 40, 50, yep, 62, and this would be centimetres squared because it's a surface area that you've worked out, nothing to do with volume. Okay, that's the end of that video on perimeter, area, volume, net, surface area. Everything you need to know.